Okay, today we're going to be doing some looking at modelling with the normal distribution. Now, we've said previously that the normal distribution is something that models real life situations. So it can model measurement errors, in scientific experiments, and when we first started talking about the normal distribution, we mentioned that it was first observed by Carl Friedrich Gauss, who was doing astronomical observations, and he realised that the errors in his measurements were giving him this kind of shape, and this is when the normal distribution was first observed. It also can be applied to things like height, weight, strength, all these different human characteristics, and so on and so forth. And so we're going to be looking at these real life situations and apply and look at questions that where we can use the normal distribution to analyse the data. So let's just jump right in with a couple of questions. The mass of newborn babies in a certain region is normally distributed with mean of 3.35 kilograms and variance of 0.0858 kilograms squared. Estimate how many babies of the 1,356 babies born last year had masses less than 3.5 kilograms. So, what we have is we have our variable x, which is baby mass, and it's described by normal distribution, where the mean is 3.35 and the variance is 0.85. Oops, missed out the 0. Oh, I'll rewrite that. 0.0858. So we can find our value for z if x is 3.5. So we've got 3.5 minus 3.35 over the square root of 0.0858, and z comes out at 0.512. So now we need to find the value for the phi function when z is equal to 0.512, which gives us 0.6957, just by go and read off the table. So the probability that the mass is less than 3.5 kilograms. So let's just draw this. Let's just draw a little. So this is our value for z, 0.512. and so this is this, that they're less than this, is going to be 0.6957, which means 69.57% of the 1,356 babies will have the mass less than 3.5, which comes out at 943.3692. But you can't have a fraction of a baby, so therefore there are about, so it's not an accurate number, about 943 babies less than 3.5 kilograms. So let's do another one. A factory produces half-litre tins of oil. The volume of oil in a tin is normally distributed around with mean 506.18 mils, and standard deviation of 2.96 mils. Firstly, what percentage of the tins contain less than half a litre? And secondly, find the probability that exactly, 1 in 3 randomly selected tins contain less than half a litre. Okay, so this is a question about errors. So obviously, if you're filling up tins, it's impossible. There's going to be variations between them, and so the variation, although it's that they're producing half-litre tins, some will be just a wee bit more than half a litre, some will be just a wee bit less than half a litre, and in this factory, the mean volume of oil in a tin is just over the half litre, is 506.18. So now X is a normal distribution with mean 506.18. Now, this is where you need to be careful. This is standard deviation, not variance. So the variance is 2.96 squared. So just be careful that sometimes they might give you the variance, sometimes they might give you the standard deviation. So now we need to find our value for Z. We're looking at X being 500 minus the mean. And because this is the standard deviation, we just write 2.96. And that gives us minus 2.088. So if we think about here is minus 2.088, and we want this this probability. So it's going to be less than, this would be less than the 500, this is less than minus 2.088. So our probability that x is less than 500 is equal to the probability that z is less than minus 2.088. So we know that that is going to be 1 minus 5 function for positive 2.088, which comes out at 1 minus, looking at the table for this, 0.9816, which comes out at 0.0184. Therefore, turning the probability into a percentage, times it by 100, there's going to be 1.84% of tins with less than half a litre. Okay, now we want to find the probability that exactly 1 out of 3 randomly selected tins contain less than half a litre. So we're going to say, this is an example of a discrete random variable. So we've got discrete random variable, and we'll call it y, and that's the number of tins with less than half a litre. So our random variable y is going to be a binomial distribution, and there's 3 in total, and the probability that they have less than half a litre is 0.0184. So in terms of our language for the binomial distributions, a success is going to be less than half a litre. So the probability that y equals 1 is, well, there's 3 tests and 1 is a success. And so then we'll times that by our 0.0184 to the power 1 times, and a failure would be more than half a litre in this case. So that's going to be 1 minus 0.0184, which is 0.9816. And it's 3, take away 1, which is 2. And plugging that into the calculator, you'll get 0.0532 is the probability of selecting one of the tins at random, 1 in 3. So I hope that helps.